This discussion is on logarithms, using rules to solve log functions. Log 8(4) plus log 8x is equal to 3. Let's begin with this problem. In order to start here, we need to remember the product rule, where when you've got a setup like this, you can rewrite this so long as the logs have the same base. You can rewrite it as log 8 4 times x is equal to 3. Notice log 8, 4x, and they're being added together, so you can rewrite it this way. Now, let's convert this to a exponential function by taking the 8 as my base, the 3 there equals to 4x. Now, what is 8 cubed? 512 is equal to 4x. Okay, do now just solve for x. Divide by 4. And so x is equal to 128. Okay, so that's how we use the product function. Let's try another problem. Let's scroll down here. Okay, log 8 to 9 minus log 8 parentheses x minus 8 equals log 8, 11. Now, when you notice that all the logs have the same base, 8, your mind may first tell you that since we have all the same bases, we can drop all the logs. That's not entirely true. It is correct if you have a log on one side and a log on the other side that is the same base, you may drop them. If that's all you have is the log. However, we have to reconcile this right here first before we can perform that operation. So we need to consider the quotient rule for our logs. And here's what we'll do. If you remember the quotient rule, it takes a log like this where they have the same bases and they're subtracting each other. And it rewrites it this way. Log 8, 9 over x minus 8. And then bring down the other side, log 8, 11. Now that we have one log here with the same base, now we can cancel out the logs and just work with the equation or the remaining numbers. 9 divided by x minus 8 equals 11. Okay, let's get rid of the fraction first, multiplying both sides by x minus 8. What happens here is these two cancel out, leaving me just 9 is equal to 11x minus 88. Next step is to add 188 to both sides. That gives you 97 is equal to 11x. Divide by 11. Your final answer then is x is equal to 97 over 11. What we do know is that 11 is prime, and I think 97 is prime, but either way 11 will not go into 97. So this is your final answer. 97 over 11 is equal to x. Alright, let's consider one more problem. Let's scroll down. Okay, let's consider this problem now. Now notice we have log 5 and log 5. The nice thing here is we're able to very easily cancel out the logs. Now, all we have left is the problem itself. 4 minus 3x is equal to 2 minus x. Well, just solve for x now. And I like to keep my variables positive, so I'm going to transfer the 3x to the other side here. Always combine your variables first. That goes to 0, leaving me 4 is equal to 2. Now, positive 3x and a negative 1 gives me a positive 2x. Alright, subtract 2 on both sides. Leaves me with 2x then is equal to 2. Divide by 2. and it leaves with x then is equal to 1. Now, I'm giving you 3 examples on how to solve logarithms, or various functions anyway, using the rules. Notice that in each case, you're going backwards. You're going from the expanded version, if you will, to a reduced version so that you can then cancel the logs out or rewrite the equation in an exponential function. So when you're working through problems, look to see what rules can be applied to get you to a point where you can either convert it to an exponential function or, like this case here, getting where you have only one log on both sides having the same base. That concludes this discussion.